In lesson 7.7, you will write and apply exponential and power functions. In our first example, we're going to write an exponential function, y equals ab to the x power, whose graph passes through 2, 9, and 4, 81/4. So to do this, we need to find a and b. So we can write a system of equations using the ordered pairs that are given. Our first y value is 9, and it's equal to ab raised to the x power, which is 2. And our second y value is 81/4, and it's equal to ab raised to the x power, which is 4. So solving this system of equations for a and b, I'm going to use substitution. I'm going to solve for a in that first equation. So a is equal to 9 over b squared. And I'm going to substitute for a into the second equation. 9 over b squared times b to the 4th power. Okay, now on the right hand side I have like bases that I'm dividing. So when we divide like bases, we subtract exponents. So that would be b to the 4 minus 2 power, or 2 power. Okay, now I want to get b squared alone, so I'll divide both sides by 9, which is the same as multiplying by its reciprocal, 1/9. And simplifying, multiplying, I can cancel that factor of 9 top and bottom, so I get 9/4. And now I need to solve for just b, so I'll undo that power, take the square root of both sides. So b is going to equal two solutions plus or minus the square root of 9/4, which is 3/2. But because b in our exponential function has to be positive, I'll choose to work with only the positive 3/2. Now I can go back up here and solve for a. A is equal to 9 over b, which is 3/2, raised to the 2nd power. Okay, so a is equal to 9, and in the denominator I have 3/2 squared, which is 9/4, but we don't divide by a fraction, we multiply by its reciprocal instead. So I'm multiplying by 4/9. 9's cancel, and I find out that a is equal to 4. So now I can write my exponential function, y equals a, which is 4, times b, which is 3/2, raised to the x power. So this is the exponential function for that graph. Okay, on the right hand side, the data shows the number y of students enrolled in an elementary school during the X year that the school has been open. We want to use the points x, y to draw a scatter plot of the points x, l, and y. So I completed this table of values for us, and we're going to graph the ordered pairs x, l, and y. So the first ordered pair is 1, 5.9. The second ordered pair is 2, 6.0. The third ordered pair is 3, 6.1. Fourth one is 4, 6.3. And the fifth one is 5, 6.4. Okay, and now you can see that this scatter plot, the data forms a line. I can draw a line, best fitting line through that data. So to answer question 2, it says, is an exponential model a good fit for the original data pairs? And yes, it is, because that data lies close to a line. Now we want to write the equation of that line. So to do that, we need to find a slope. And we're going to use 2 points. I'm going to use the first point and the last point to write the equation of that line. So I'm going to subtract 6.4 and 5.9 in the top of my slope. And in the denominator, it's going to be 5 take away 1, those x values from the points I chose to use. So in the top, I'm getting 0.5, and in the bottom, 4. So when I put that in my calculator, I'm going to get 0.125 for a slope. And now I have a slope, and I can choose one of these points and write my equation of that line in point slope form. Y take away y coordinate is equal to the slope times x take away an x coordinate. but our y value is really ln y, and the y value I chose to use is 5.9, so that's my y sub 1 value. We found the slope to be 0.125, and x, take away x sub 1 is 1 from the point I chose to use. Okay, now getting this equation in proper form, I'm going to distribute on the right, so I get 0.125x minus 0.125, and I'm adding that 5.9 from the left-hand side. Now I can take a step to combine like terms. So I have 0.125x, and more positives here than negatives. So it looks like 5 and 7 and 7. So 5.775. Now that I have my log alone and I'm simplified on the right, I can go from logarithmic form to exponential form. My base is e. It's raised to the 0.125x plus 5.775 power equals y. And now I want this equation in y equals ab to the x power form, so I'm going to separate my base so that it reads e to the 5.775 power times e raised to the 0.125 x power. So now I can approximate my a value and b value and write my equation. So I'll use my calculator to put e to the 5.775 power in my calculator. And I'll round to a whole number because this represents the enrollment in an elementary school, so we'll round to the nearest person, 322. And my b value, e to the 0.125 power, is 1.13, rounding to 2 decimal places, which is good here. So there's our model, exponential model for that data. Okay, on this page we're going to write a power function y equals ax to the b power whose graph passes through 3, 8, and 9, 12. So this time we want an equation in this form, and we still need to find a and b. So we'll write a system of equations again. My first y value is 8. It's equal to a times x, which is 3, raised to the b power. And my second equation has a y value of 12. It's equal to a times x, which is 9, raised to the b power. So in this system of equation, I'm going to use substitution again. In the first equation, I'm going to solve for a. It's equal to 8 over 3 raised to the b power. And I'm going to substitute into the second equation for a, 8 over 3 raised to the b power times 9 raised to the b power. Okay, now if I'm going to combine those bases on the right-hand side, I need a common base. So I can rewrite 9 as 3 squared raised to the b power. And in the denominator I have 3 raised to the b power. So now I can divide both sides by 8, and I can combine my like bases here that I'm dividing by subtracting those exponents. 2b take away 1b is 1b. And now to go from exponential form to logarithmic form will allow me to solve for that exponent b. b is equal to log base 3 of 12/8, which, getting rid of a factor of 4 top and bottom, simplifies to 3/2. So using a change of base formula, I'll approximate b using the ln of 3/2, which is 1.5, over ln of 3. So putting that in my calculator, excuse me, I have ln of 1.5 divided by ln of 3, and I'm getting 0.5 0.369 for a b value. Now I'll go back up here again and solve for a. A is equal to 8 over 3 raised to the 0.369 power. We'll approximate a in our calculator also. Excuse me again. 8 divided by 3 raised to the 0.369 power is giving me approximately 5.334. So now we can write our power function. Y equals a, which is 5.334, times x raised to the b power, which is 0.369. There's the power function for that graph. Okay, on the right hand side, we want to use the given points xy to draw a scatter plot of the points lnx, lny. So I've created the table again to save us some time and fit this problem in, and graph those ordered pairs lnx, lny. And now you can see that they do form a line also. So to answer the second question here, is a power model a good fit for the original data pairs xy? And we can say yes, because the ordered pairs lnx, lny form that line. So I've gone ahead and I've used the first point and the last point to find the slope for our line. And now we're going to use that point slope form, and I'll use that first point 0.9 to write the equation. So y is lny, y sub 1 is 0.9, the slope is 0.5625 times x, which is lnx this time, minus x sub 1, which is 0. So now we want to get it in proper form again. So we'll distribute on the right, getting 0.5625x lnx minus 0, or plus 0. And I'm adding that 0.9 from the left-hand side. Okay, now I can go from logarithmic form to exponential form. My base is e. My exponent is 0.5625 ln x plus 0.9 equals y. And separating that base again, y is equal to e to the 0.9 power times e to the ln x raised to the 0.5625 power. I'm just going to tuck that factor outside of the log inside as an exponent. Okay, and now looking at this log right here, this e raised to the log power, we know that that has to be, if I solve for that exponent, ln x raised to the 0.5625 power, is equal to log base e of some value. Okay, that value has to be x to the 0.5625 power. So now we can write our equation. It's y equals e to the 0.9 power, and I'll approximate that value. That's our a value, and it's 2.46. Okay, times x raised to the 0.5625 power. So there's our power model for this data. Y equals a times x raised to the b power. Include with your notes of this video guided practice problems 1, 5, and 9 on pages 531 and 533 of your textbook.